Gentlemen, welcome back to my channel. Welcome back to my channel, guys. Before I start the video, just make sure to join the community by sharing this video, by liking this video, and also the most important part is to subscribe to this channel, guys. So I'm gonna give you 1 minute. So I won't talk at all for 1 minute. All right, cool. So I'm gonna go back to Robot Structural Analysis Professional, and I'm gonna show you every day. I'm gonna show you how to design different type of beam, right? And today we're gonna use simply beam, right? So it means that one side of the beam it's pin and the other side is roller. Okay, so it's simple to understand. So this robot structure, I'm gonna go on File, and then I'm gonna create a new file. Then I'm gonna select the first project. Sorry. I'm gonna wait a little bit, and when the project starts, I'm gonna go here. I'm gonna click on unit here. Just click on unit here at the bottom here, at the right bottom, and here you can change the unit according. I don't like using feet. It's kind of a little bit complicated. So what I'm gonna do here, I'm gonna change everything here in metric units. It's better to use millimeter for everything, so it won't be more confusing. Let me just take mirror. Let me take mirror. So let me just take mirror. All right, so just change everything. I'm gonna take mirror square, and here I'm gonna take mirror, and here also I'm gonna take mirror, and the thing and other thing that I'm gonna take also mirror. After the dimension, we have force. Just click on force here. I'm gonna change to kilonewton. I'm gonna take kilonewton mirror, and the other force. I mean, for the moment, I'll take kilonewton mirror, and then for the length it's automatically changed because of change the dimension. Okay, so I'm gonna click on OK, and then if you go on other forces, that's in this video I won't use any of these forces. I won't change anything here, but if you have a complex design, you need to change all of this as well. So this should be mirror, the degree should stay constant. The rotation should be degree. The temperature should be Celsius. The weight should be kilonewton, and then also for the mass, it should be kilogram. Okay. All right. So I won't change anything of this because I won't use it. So I'm gonna just click on OK here and OK. And then the next step, the second step after changing the unit is when we're gonna start designing. I'm gonna start the simple beam, right? So I'm gonna just click. If I go on my right side here, at the corner here, we're gonna see we have beam, we have columns. So I'm gonna pick beam, okay. And in the beam section here, we have the first indication that we have numbers. It won't change. It's gonna change according to how many beam that you design. So this is not important. So the most important here. So you can change the name if you want to change the name. You can change the name, but it's not important to change the name. So so the next part is the properties. We have the section type. So I'm gonna use reinforced concrete. So I'm gonna click on this part here. Under section type, we have steel beam, we have timber beam, and we have reinforced beam, right? So I'm gonna pick reinforced beam. And then for the section, so before you send any beam, you need to have your specific dimension. Okay, you have to have your height, and you also need to have your width. Okay, it depends which kind of section you're gonna use. So I'm gonna use the square section. This square section, we will have beam and an edge, and we will have the width and also the edge, right? But if you're gonna use other section, you're gonna have a lot of components to include. So I'm gonna pick the first one, this shape here. And for the beam, for the B, I will take 0.5, and then for the H, I'm gonna take 0.9. Okay. And the color should stay the same. I can just take yellow color, then add it, and then close, and then I can start designing. Right. So if you click on the beginning here, the first geometry size, right? If you click here and then you click outside the box, then we can just click at any end. So we have to have the beginning point and also the end point. So then just click on any of these. This point should be here. Now we have our beam. Okay, so I don't need this anymore because it should be a simple beam. I'm gonna close it, and I'm gonna zoom a little bit to have our look. Okay, so here I have my beam. So this is the second step. So for the second step, for the third step, is where you have to apply the load. So just go and load a load form here, and take load type. And for the nature of the loads, click here. So for my beam, I'm gonna have only two type of loads. Okay, today I'm gonna have only one type of load. I'm gonna use dead load. So dead load is the weight of the beam. It won't change no matter what. Is the weight of the beam. It can be the material of the beam. So just the safe weight of the beam. And also we have the life load. Life load is the load that can change on the beam, like the movements of people walking on the surface. That surface is considered as a beam, right? And many other forces that can move on the beam. Okay, so it's life loads. We also have the wind loads. It's caused by the wind. We have the snow loads. It's caused by the weight of the snow, and also we have the seismic loads caused by the earthquake. Okay, so in today's video, I'm gonna just consider the dead load and also the life loads. So I'm gonna just click on life loads and then add it. Okay, and here for the nature, I'm gonna click again on the nature. Then I'm gonna pick live load. Then you can see the abbreviation is changing, okay? Become LL1 for the live load. Then I'm gonna click on add. And after that, I'm gonna just click on close. All right, so we have defined our load, but we didn't apply the load yet. So I'm gonna go again on the load definition now. Is the time for me to start applying the load. Okay, so this is the next step. So now I have the beam and I have the load. So the first load that I'm gonna apply is the live load. So the load that can move, can vary on the beam, and it should be uniform load. So it should occupy every extremity of every centimeter, every meter of this beam, right? It's like every section should have that load. So it's uniform. So it's equally distributed across this beam. Okay, so what I'm gonna do here, I'm gonna just go on a load definition, and I won't take the node type or the member type. I can take the surface or I can take the member, both. Okay, so in the video, because I'm using a simple beam, I'm gonna take the member loads. Okay, and the first one I'm gonna take is the uniform load, the first one here. And for the X, because we don't have any force, we can see the picture here. We don't have any force in X direction is the horizontal forces, and Y direction is the vertical forces, right? So in X direction, 0, right? We don't have any force, and there is not any force inclined, right? So all of the force are straight. You can see here. So in X direction, it's gonna be 0, but in Y direction, I'm gonna take 50. I'm gonna take 50. Let me just take 50. But since the load is pointing downwards, so it should be negative, so I'm gonna add a negative sign in front of that. It's so important for the stability of the house if you're using this kind of beam, right? So you have to consider this small error that people usually make. Okay, and for the coordinate system, I'm gonna use the global type. Okay, then here I'm gonna just add my load. Now, first of all, I'm gonna add it. Then I need to know where I should add this load. So it should be the entire beam. Okay, I'm gonna just click on apply and then select the all beam. Okay, then click again apply. You can see now we have our loads. Okay, then we can just close it. We can just close this section. It has been verified. Okay, and then next, if you go again on the load and then go on load definition, I should be dead load here, by the way, but it's okay. Here I'm gonna define, because I said before this beam should be simple beam, means that on this side, the first node, it should have forces in X direction horizontal forces, and in y direction vertical forces. But at the end, this end part here should only have forces in y direction, like vertical direction. Okay, and all of them should be positive because all of the forces that they're pointing down upwards. Okay, so what I'm gonna do here, I'm gonna click on the load definition, then go on member, then after the member, I'm gonna pick the node forces here. So I need my x direction to be, let's just say 50, and the y direction here should be fixed 50. Okay, and all of these loads are positive. Okay, I don't have any moment on this load because it's simple beam, like very simple beam. Okay, and now I can just click on add and then apply. So it should be only apply at this junction, this node here, node 1. Just make sure it's been selected, then click. Yeah, it has been selected. You can see, right? We have one load in y direction and another load in x direction. So now I'm gonna repeat the same process, but I won't put any force in x direction. I'm gonna put it in node 2. So what I'm gonna do here, I'm gonna go again here. Let me just close it first. Let me just close it and then go again on the load definition, nodes, and here for x direction it's going to be 0. I don't have any force in x direction, but in y direction it's going to be also positive forces, right? So I'm going to just click on add and then delete this one, put 2. Or if you're not sure if you are not sure about the node number, just go here and click on this 2 and then click on apply, right? And then close it. So now we have defined all of 3 loads. The first, it's uniform loads across the entire beam. Second of all, we define the support of the loads, like in one node and also the second node. Okay, so now our point is to find the calculation of these forces. So I'm gonna go on analysis. I'm gonna go on analysis type. No, it's not important now. I think now it's not important because it's like kind of a little bit simple beam. So what I'm gonna do, I'm gonna just display the beam and then I'm gonna see how it looks like. So I'm gonna go down here on my left side and we're gonna see load value description. And after the load value description, we also have the load symbols. Now you can see how the load that you apply on your beam. You can zoom a bit. So this is how our beam looks like. So the uniform beam on the uniform load on the beam is 50, but it's pointing downwards. The support of this beam are 50, right? And it's simply beam, right? It means one part of the beam is, this part of the beam is a pin support, and this other part of the beam here is roller support. So the next thing that you have to look up is, after calculation, is how much loads this what's the maximum force of this beam before it's cracked. So this is gonna be our next video. So if you find this video so entertaining and also educative, don't forget to share the video, like the video, and also subscribe to the channel. And if you have any design ideas, if you need to customize your house, any type of structure that you want, just hit me up. See you in the next one. Bye bye.